Let's go through Liquid 2139, minimal swap to group all one together, 2. So it gives us a binary array, which is the number in this nums array are 0 or 1. And it says that it is a binary circular array. So what is a binary circular array? Is that the index 0 and the last index in -1, they are adjacent. So it is like a circle. So let's return the minimal number of swaps required to group all one together in the array together in any location. So for this question, if we want to group all the ones together, the one can have two shapes, two types of shapes. One is like this in the middle, right? They are put together, and this is the total array, and the others are 0, 0, right? So this is one of the scenario. Another scenario is the one is at the beginning, and another part is at the end, right? So we need to handle two cases, but we can simplify this one as one case. That is for the second case, we're trying to group all of the zeros in the middle. So it will be simplified to be from the circular array to a regular array, right? So we want to ask what's the minimal swaps we need to group one together, right? Then we can do the same thing with what's minimal swap to group zero together. So how can we handle what's a minimal swap to group one together, right? So we know for this number, for example, there are k ones, right? So we can group something like the k ones in this window or in this window, right? Or in any of this window, right? Until it's just like a sliding window until this k is this k window, the right end just end with n-1, right? So we want to find for all of these windows what's the minimal swap. So for one window, how many swaps needed is in this window, how many ones, right? So for example, this is k equals, for example, equals 10, right? So if this window have 8 ones, then we need 2 swap, right? So we just have a fixed slide window go through from the beginning to the end, trying to see which window has a minimal swap. Then we do again for the minimal swap for the zeros, right? Write code, we can use one for loop to do this, right? Instead of use 1 and 0 twice, we can use one for loop. So let's write code for this. We're going to have n equals nums dot length, and we have one count equals 0, right? So for into 3 in nums, and one count should plus equal to v, and we're going to have int 0 count, which will be n minus 1 count. And we need a window 1 count equals 0. Window 0 count equals 0, right? And we need a result because integer dot x value. Then what we do is that for int I equals 0, I smaller than n, I plus plus. So I can have a window 1 count plus equal to nums I, and window 0 count is plus equal to, let's say we can have 1 minus nums I, right? So that means if it is 0, we'll add 1. Or we can use XOR, right? So let's say if I is greater equal to, so there are two windows, two sliding windows. One is 0 count, another is the 1 count, right? So if this one is greater than one count. So we'll see, we'll have the window one count with a minus equal to nums I minus one count, right? And we'll see if this I is greater equal to one count minus one, right? Then we can have one candidate result equals math dot mean result should be one count minus Windows one count, right? We do this for 0 as well, right? So if I is greater equal to 0 count, then we're going to have 0 count Windows 0 count minus equal to the 1 minus nums I minus 0 count. And we'll say if I is greater equal to 0 count minus 1, right? So we have another candidate result equals math dot mean result 0 count minus Windows 0 count. And then in the end, that's the return result. It will be O(n) time complexity with constant space complexity. And Python code will be very similar to also write Python code for this. We're going to have n equals and one count. This one equals length of nums, and this one equals the sum of nums. So let's say b count equals n minus one count, and we're going to have Windows 0 count, Windows one count, and result 0 0. Below and so I is going and not going to have Windows one count to the plus equals nums I, and the Windows 0 count the plus equal to 1 minus nums I. So we'll write if I greater equal to the one count window, right? Then Windows one count should minus equal to nums I minus one count. And we'll say if I greater equal to 0 count window, if you have Windows 0 count minus equal nums I minus 0 count window. And also if as long as we have such a window, right, if I greater equal to 1 count minus 1, we have one candidate result equals mean result 1 count minus Windows 1 count. The thing that here we cannot use 0 count directly, because otherwise we need to make sure it is already being updated. We can use for example, their win0 count here. Write something like win0 count, something like this, win0 count is minus equal to 1 minus num I minus something, right? In this case, we can use a win0 count, right? But the thing is that I think 1 count minus win1 count is more straightforward, right? And if we just write the line 10 and here write when zero count, it will not be correct because it's not possible. It may not be updated, right? And we'll write if I greater equal to zero count minus 1, we are going to have result equals mean result zero count minus Windows zero count. So in the end, just return result. Let's take a look. So Windows, if minus equals to, so this is the thing that this is my 1 minus, right? So zero count is should it be 1 minus